This video will demonstrate how to develop a multiplicative return model to simulate some asset prices. In this case, we have a series of prices for SPY, which is a mutual fund that mirrors the S&P 500. So a multiplicative return is the ratio of the current price and the previous price. These are monthly prices. So the most recent is August. The previous price is July. And so the ratio of those two will be the multiplicative return. Multiplicative returns a lot of times are fairly close to 1. They can be a little bit less than 1, a little bit more than 1. Now, there's some strong empirical evidence that the multiplicative returns on stock prices or mutual fund prices have a log normal distribution. So we'll fit a log normal distribution in this case. So we're going to calculate over here the mean and the standard deviation of the multiplicative returns. We'll calculate the mean using the average function. And the standard deviation using the stdev.s, which is the sample standard deviation. So we see the mean and standard deviation of this log normal distribution. All right, so let's fit. Down here at the bottom, we'll go ahead and simulate this. We have the August price, that's the most recent price. And then we'll simulate this mutual fund price for 5 months. Up to January. And so the August price was the last one. I'm just going to repeat it here to make this formula simpler. So that's just a reference up to the top. And then we'll simulate 5 log normal random variables for the next 5 multiplicative returns. So we'll develop a distribution, define distribution, and the log normal is a continuous distribution, so we'll search in the continuous category. And since we have the mean and standard deviation of the distribution, we're going to use the first option for log normal. We enter the mean and standard deviation of the log normal distribution here. And we can do that with a cell reference by clicking on the small red arrow. That's the mean. And that is the standard deviation. Because we want to copy these down ultimately 5 times, it would be advantageous to go ahead and put in the absolute reference on the row. And we'll click OK. And so now, if we double click here, we have a log normal at-risk distribution. And we have an absolute reference on the row for the mean and standard deviation. And we'll copy this down. Now, these are the multiplicative returns. So the new price in the series would be the previous price times the multiplicative return. Previous price times the multiplicative return. Previous price times the multiplicative return in column C. And we can just copy these down. Now, these are the new prices we're simulating as a forecast for the stock price, so we could define any one of those we wanted to as an output. We'll go ahead and define here the January price as an output. And then we'll just simulate it for 1,000 iterations. And so we can see that the mean of the simulation is about 132.86, and the standard deviation is about 11.505. And we see the distribution of the values for the potential January 1 SPY price. 90% of those fall between 115 and 152.7. The next video will build on this to simulate the same time series with the geometric Brownian motion model.